So the first thing you need to know, the first thing that you guys need to know is there's two different types of trapezoid. There's just a trapezoid, and then there's an isosceles trapezoid. So we know in an isosceles triangle how many sides are congruent. 2. So in an isosceles trapezoid, 2 sides are also congruent, and we'll talk about what those mean. So you guys need to understand what all of these words mean. So these are base angles. Both sets are base angles. It doesn't matter which one it's sitting on, because it could sit up here or it could sit down here. So these are both considered bases. The sides that are parallel are the bases. So the parallel sides are the bases. So the parallel sides are the bases. So a quadrilateral with exactly one set of parallel sides is a trapezoid. Those are known as the bases, so the other sides are the legs. They could or could not be congruent, so other sides are considered the legs. If those legs are congruent, you see how these legs are marked congruent? If the legs are marked congruent, then you have an isosceles trapezoid. So if you have congruent legs, then it's an isosceles trapezoid. Otherwise, it's just considered a trapezoid. So understanding what all of those pieces are is very important. Are we confused about anything considering the base or the legs? Okay, so let's get started with the construction of a pair of parallel, or constructing a trapezoid. So the first thing we're going to do is construct a set of parallel lines. So grab your straight edge. I'm going to do it off to the side here. I don't know where my straight edge went. Does anybody see my straight edge? Somebody feel it?
Yeah, because someone just wants to steal.
Well, why wouldn't you want a meter stick?
It's literally their big.
Where is it? Okay, honestly.
How do you lose a meter stick?
That's a good question. How do you lose a meter stick? Well, apparently I didn't, so.
It's right here, Miss Ratty.
Where?
Right there.
My compass is right there. Where's my
It's right
meter
there.
stick?
It's right there.
I'm pretty sure you're
In your hand.
I just grabbed a new one, that's why.
sports.
All right.
Right.
So, the first thing you're going to do is draw a line segment and label a point P above the line segment. So, everybody, draw a line segment with your straight edge and label a point P. Okay, guys, let's go. Start constructing.
Miss Brady,
What?
is it supposed to say code?
Yes, it is.
Miss Ratty, how do you know where to put the
Yeah,
point?
watch it point there.
It just point off the line above the segment.
Okay.
You also are not even on the right side.
I was turning to it. I was trying to get a straight edge. Yeah. So judgmental.
Hey,
Take your test and leave us alone.
Okay, so it says draw a line through one of the endpoints of the segment, and we'll call this point X, and point P, and this will be sure to extend the line past point P. So we call this X, and I'm going to draw a line segment that connects it past those two. So I'm going to connect those 2 points, but I'm going to make sure to go past my line segment.
You went past a lot.
Yes, it's good to go past it a lot.
Great, you.
Okay. We're constructing a trapezoid. Okay, so then you're going to place your compass, the sharp end of your compass, on point X, and you're going to draw an arc that intersects both segments. You're going to label point A and point B on the 2 segments. So you're going to put your sharp end and draw an arc that hits both sides. Do not change the width of that. And I'm going to call those point A and point B. Point B needs to be collinear with point P.
I didn't even look.
Don't forget to label your points as we're going here. Those are just the ratios. You don't need that. Okay. So with the same compass setting, place the compass at point P and draw an arc. Draw a wide arc labeled point C. So we are going to continue with that same compass setting. And we are going to start at point P. And we're going to draw a wide arc. And call the point of intersection of that black line and the red line point C. Make sure your compasses aren't moving. Some of your compasses are moving. Sometimes it's easier to move the paper. You want it to go to point P and hit up here. Look at where my point C is. My point C is on the same line as P. That's not going to work. Guys, make sure your point C is on the same line as P. Collinear with point P. Mine does not even hit this arc. Not that it matters, but mine does not hit that. Okay. Now we're going to adjust the compass setting to measure the distance from A to B. So we're going to put a point at A or a point at B and one at A and just measure that distance. So I'm measuring the distance with my compass. So all of you should be doing the same thing. Measure that distance with your compass. 1 point on B, 1 point on A, and pull it off. And then you're going to place the compass at point C and draw an arc that intersects the other arc already. So I'm going to take this. Mine is not going to be parallel because my compass doesn't know to stay straight. And you are going to label that point D. Okay, if you are confused or not here, let me know. Yours should look more parallel than mine. My compass is moving a ton. Please let me know if you need me. Is it? Mine is, I think my compass just moves way too much. So this should be parallel with the base, but because of where my compass is at, it's not. So we have our line here. You don't want to connect it to A. You have to make it wider than that. So we're going to connect it just down. It can be any point along this line. I'm going to name it Y. So then you're going to label this. So those are parallel. Not that mine look parallel. So we're going to label it, and we're going to say PD is parallel to XY. And that's all you know in this here. Okay. I just grabbed B and just drew a line, slanted downwards. It doesn't matter where. And I made Y. Yeah.
It's a rhombus.
Yours is not a rhombus. That is not a rhombus. That is a trapezoid.
It's a triangle.
Still not a rhombus. Yes. What letter? D?
With angel wings.
So you measure from here to here. And then you put the pointer. You draw an arc that.
Bro, you were on the wrong one. Had us on that.
Anybody else? Before we do an isosceles.
No, she put me on the.
Make sure you draw a line down.
Miss Brady, look what you did. You flipped me to this page and I did it on that.
Make sure you switch those. Sorry.
Switch one.
Like, put the right thing. Just put trapezoid, cross out isosceles, and just put trapezoid. All right. Next construction. is an isosceles trapezoid, although I accidentally made Ian do it on his.
Can you leave that up there for?
Yeah, I am. I was going to go over there. Or here. I don't know. Which better. Okay. Draw a line segment and label a point P above. Again. Maybe this time my line will come out parallel. It's going to start out pretty similar. So draw a line through one endpoint of the segment and call it X, and through P, and make sure to extend that line. Okay, so then you're going to take your compass and put the sharp point on X, extend it out, and draw an arc that hits both of those segments there. So, putting it at X, drawing an arc with a marker that's not working, with a
Can it be like any width?
yeah.
Call this point C.
She said it called.
Oh my gosh, this is driving me insane. I have to get a new marker.
P right there.
So this is B, and this is A. I'm sorry, you can't even see my arc. Let me grab a different marker.
Probably because the angle of that monster is weird.
Yeah, and I think it's I know, and now I have to redo it anyways because I just changed the width of my. Life is rough.
Oh my gosh.
I'm getting frustrated too, Kylie. I feel you. Look at this. My rubber
I
band.
cannot get this to stay still. And it's like
Did it
you
just
come
break?
and it has to be exact.
My rubber band decided to break. My compass isn't even at the right width anymore.
This bright makes you feel better on the last one. I just copied what you did. I didn't even use straight up your
Well, that doesn't make me feel better. That actually makes me feel worse. So you need to know how to do it with the compass and the straight edge.
You're wrong.
Look at it. Am I doing this?
Okay, so
Fred, you
in a second here.
I didn't even look.
All right, let me try this again.
Oh my gosh.
You put it on P.
Okay, so that looks pretty good. So from there, you keep your width the same, and you're going to place your point at P and draw another arc so that it hits the line with P and B.
Point C.
Did you do it wrong, Greg?
Yep.
At least you learned right now that you did it wrong, right?
Wait, did you go from B or P?
I went from P. So putting your sharp end at P, keeping it the same width, you're going to draw an arc. So put your sharp end at P and draw that same arc through there.
Same width.
Same width as the one that, like this first green arc, okay? Once you are done with that, go ahead and start measuring the width from A to B with your compass. From A to B, not X to A. A to B with your compass. Measure that width once you are done. Take your compass, widen it out, and measure that width from A to B. So I'm going to put one of my ends at B, widen it till it's at A. So I have it measured. Do you guys all see that I'm just measuring it? Are we all measuring?
Yes.
Okay, from there, this here is point C, where it intersected. I'm going to call that point C. I'm going to put my compass at C and draw an intersection of the arc drawn at P. So we're going to draw, make sure it intersects that arc there, and we're going to call that point D.
Oh no.
So this is where it's going going to get a little bit different. You can't just draw a line down. So you're going to connect P and D. So go ahead and connect your P and D, but then you're going to have to wait a second. So connect P and D so that these two are now parallel. So we do have PD parallel to XA so far. Is your compass moving along?
And then you just draw a line.
Okay, so we now need to make an isosceles trapezoid. An isosceles trapezoid means two of the sides are congruent. The leg sides, for that matter, not the parallel sides. So we have the base sides done. So we need to make the same length as XP from D. So we're going to adjust the length of the compass to measure the length of XP. So measure the length of XP now with your compass. Everybody measuring. Measure. Measure.
Oh my.
As I erase the dot again.
Wait, which one are you doing?
Measure the length from X to P.
Are we still on the same one?
Yep. X to P.
Jesus.
X to P. Place the compass at D and draw an arc that will intersect the line XA twice and label the outermost part of the arc Y.
What?
So I'm going to do this. Watch. Do you see how mine hits twice? So you put the up here. This is the outermost one. Do you see how it's outside of the trapezoid? Do you see if you went this way, it wouldn't look like a trapezoid? So that's why we're labeling the outermost one Y.
Mine didn't do that even when I measured.
You're lying now.
Did I do this wrong?
Yes.
Obviously.
Yeah, your line isn't parallel, that's why.
Well, that's dumb.
So your lines may not be parallel if it didn't hit there. Just so you guys are aware. I lost my...
Did I do this wrong?
I don't know. I'll look at it in a second.
Well, did it go through it like ours did?
Because Rob's didn't go through it because it looks like his lines aren't parallel. So if it's not parallel, it may not work. All right. So that means that these two segments are congruent. So PX is congruent to DY. Okay, I'm going to come around real quick before we finish up notes because we still have notes to do too. This is why I'm not handing back the test today. Let me see what you guys need from me. Make sure you're creating that isosceles trapezoid. Connect these 2 points, please.
Gosh, he barely misses.
Just eyeball where it is about then, Robin. Connect. Does anybody not have an isosceles trapezoid? Yours does not look isosceles. Yeah. One second.
What is that? Y? What is that?
We'll be fine for a little bit, but it's going to loosen out again. It's not going to stay that way. Yeah.
Did I do that?
Yeah, that's fine. Does anybody need me? Because theirs isn't done. Okay, so just connect here. Anybody not have an isosceles trapezoid? Maybe?
I don't think what makes it isosceles.
Mine's not, I don't think.
Did yours not hit either?
Well, like, that's not right.
No, it's because your line's not parallel. So it's not right.
Yeah, my lines are.
So, you need to, did you go from here to here? And then you went from here, do that. You have to do this, so that will create.
There you go.
I tried doing it without
Okay? Does that help you?
You want to put the-
Alright guys, we're done with the constructions. You can do 2 of the constructions in your portfolio now. Okay. Everything else is okay. Just make sure it's guys, don't forget to label like I did. I labeled my parallel sides and I also labeled my congruent sides. So make sure you're doing the same thing I'm doing up there. When you're ready, go ahead and flip so we can continue on with our notes. I don't know. I need to talk to our counselor. Hey guys, you know that pink sheet? that I handed to you at the beginning of class?
Yeah.
These are the properties of just a trapezoid and an isosceles trapezoid. So you might want to at some point go through that pink sheet, and we can kind of talk about that together in just a second here. After I read through these, we can read through them on there and make our X's. Does that make sense? So first of all, the properties of a trapezoid are as follows. The bases are parallel. So the bases are parallel. Each lower base angle is supplementary with an upper base angle. So I'm going to call these C and D. So those are also 180. And those are just the properties of a trapezoid. So let's go through our trapezoid properties real quick here. Actually, let's talk about the isosceles. We can do the thought one. Okay, the properties of an isosceles trapezoid have a lot more. Everything from above is true, along with the legs are congruent by definition. So these things are the same. The base angles are also congruent. So the lower base angles and the upper base angles are congruent to each other. So these ones, B and C, are congruent to each other. And A and B are congruent to each other. So just to give you guys what those are. So AB is congruent to CD. Angle A and D are the lower base angles that are congruent, and B and C are the upper base angles that are congruent. Any lower base angle is supplementary with an upper base angle, meaning that angle A plus angle B is 180, and angle C and angle D also add to 180. Diagonals connect opposite points, and we know that the diagonals are congruent, so BD is congruent to AC. So let's go through this pink sheet, and we're going to just do the last two columns together. So in the pink sheet, just look at those last two columns. Everybody get that out. So are both pairs of opposite sides parallel? Are both pairs of opposite sides parallel? Both pairs are? These two are parallel, but are these two parallel? No. So do you get check marks in either of the isosceles or trapezoid box? No. Exactly one pair of opposite sides are parallel. Yeah, so that's true for both trapezoid and isosceles trapezoid. So exactly one pair of opposite sides are parallel. It's true for both isosceles trapezoid and trapezoid. So put the marks there, or however you want to mark it. Does it tell us anything about the diagonals being perpendicular, meaning form a right angle? Is there one thing that says anything about that up there? No. Okay, the diagonals are congruent. Are they congruent? Does it say anything about that in just a normal trapezoid? Any given trapezoid? How about an isosceles trapezoid? Does it say here? Doesn't it say the diagonals are congruent here? So just for the isosceles trapezoid, don't do it for both. You have diagonals that are congruent. The next one there says diagonals bisect each other. Does it say any word that says bisect up there? No, so that mustn't be true.
Is this just for normal trapezoid? Like,
We're doing both right now. So these two should check here. Diagonals bisect opposite angles. Again, do we even see the word bisect on here?
No.
No. Both pairs of opposite sides are congruent. First of all, in a trapezoid, none of these sides need to be congruent, right? And this side, is it both pairs that are congruent, or just one pair? Just one pair, so that's not true. How about exactly one pair of opposite sides are congruent? That's true for just the isosceles trapezoid. So in the exactly one pair of opposite sides are congruent, mark isosceles trapezoid. All sides are congruent. I've been using this one. It's the one I grabbed from the corner. So are all sides congruent? No. Both pair of opposite angles are congruent. So these are opposite angles. Are these opposite angles congruent? No. Exactly one pair of opposite angles are congruent. No, those are consecutive angles, so we can't really say that. All angles are congruent. No. Consecutive angles are supplementary. Technically, this is not true for either of them. These two are supplementary, but are these two supplementary? No. So we can't say that one for this one because it's not all sets of consecutive angles are supplementary. Each diagonal separates the shape into two congruent triangles. These are not congruent triangles. And opposite angles are supplementary is not true of this one. Well, actually, opposite angles are supplementary in an isosceles trapezoid. So opposite angles are supplementary only in an isosceles trapezoid. And I'll confirm all this stuff with you guys because some of the wording on here is a little bit confusing. That's why I kind of want to go through this as we learn more properties. So at least you have that marked, and now we can use our properties to do some algebra stuff with it. I know. Okay, let's continue on. We have 13 minutes. So, in example below, trapezoid WXYZ is an isosceles trapezoid. So we know opposite sides are parallel, we know the legs are congruent, and we know these diagonals here are also congruent. If it's an isosceles trapezoid, those are some of the properties we know that we just learned from the previous slide. So it tells you YZW is 45 degrees. WV is 15. And VY is 10. So I'm labeling what I know. So it says find the measure of XWZ. So XWZ is this angle here. How do we know? What do we know about base angles of an isosceles triangle? Base angles of an isosceles triangle are angles can't be parallel. It is 45 degrees, but that's not what they always are. Base angles are congruent. So base angles of an isosceles trapezoid are congruent. So if that is 45 degrees, that means that this is also 45 degrees because base angles are congruent. How about the measure of WXY? How can we find the measure of WXY given our properties from the previous slide? What do we know about WXY from the previous slide that can help us find that angle measure? What do we know? Consecutive base angles are, what does it tell you in the previous slide? Look up there. Yeah. Supplementary. So we know that they must add to 180. So I take away 45. Because consecutive base angles are congruent. You guys should be writing this down. It's the first Monday of the month. I don't know. I have to look. I think so, though. I think it's this Thursday. It's this Thursday. I have like 11:55 dismissal. Okay, XZ. XZ. What is the length of XZ? What do you know about these two diagonals? They are congruent. So XZ is congruent to WY. What is the length of WY? What is the length of WY? Guys, you have a homework to do. It's 25, so that means that this is also 25. Diagonals are congruent. What do you guys think the measure of XV is then? This is XV. What do you think this is? What does it look the same as? VY, right? And what is the length of VY? So this must be. Okay. Questions on those ones. Big thing here is that you guys don't know the properties yet. So you guys are going to have to actually look at the properties as you're doing your homework. Does that make sense? And have those memorized. Okay, continuing on. Get that stuff written down so we can flip to the next slide. All right, guys. Mid-segment. Defined as the mid-segment created by the midpoints of the legs. A trapezoid's mid-segment is also parallel to its bases. So a mid-segment connects the midpoint of each of those separate legs. And we know that the mid-segment is half of the lower base and the upper base added together. So you take half of the lower base and the upper base added together. So if you know that it's a mid-segment, then you know that it's parallel. And you know that it's half of the upper and the lower base added together. So let's go through this one. So we know to find x, since that's a mid-segment, since these pieces are halfway in between, we do 20 plus 40 divided by 2. So what is the length of that mid-segment there? What is the length of that mid-segment? 30. Again, to find the mid-segment, we do the mid-segment, which in this case is 15, and you do x, the upper base plus the lower base, and you divide by 2. So how can we solve for x in this problem? What would you do first to solve for x? Yeah. I would multiply by 2 on both sides. So I get 30 equals x plus 18.2. What is 30 minus 18.2? Can somebody do that for me? So 11.8. Yeah, okay. So we know that that upper base is 11.8, and it would be in inches. I keep forgetting the units. Sorry, guys. So this one should be in meters. Okay, questions on the mid-segment. Yeah.
So if it's the number in the middle, that's like the number on this side?
Yeah, it's the equal. The mid-segment is the equal part.
And so then the on top.
And you add the number on top plus the number on bottom. Okay. What kind of trapezoid is this, and how do you know? What kind of trapezoid is this one, and how do you know? It's isosceles because its legs are marked congruent. So we know JML is 130. JN is 6.7, and LN is 3.6. What is the measure of MJK? So what do you know about consecutive base angles in a trapezoid? Consecutive base angles of a trapezoid are? They're not congruent. Legs are congruent. Those are supplementary. So we do measure of angle MJK plus 130 equals 180. So that is 50. Okay, what do you know about the diagonals in isosceles trapezoid? They are congruent, but it says to find JL. What are we going to do to find JL? What are we going to add together?
6.7 and 3.6.
Good. So that's 10.3. Okay, let's just do this last problem here, and then I will get you guys your homework. So, we are going to assume, even though it's not marked, we need to assume this to do this problem, that this is congruent to this, and this is congruent to this. It should have been marked. I'm sorry, that's my fault. As Lindsay said, the middle segment is equal to the top and the bottom segments added together, right? And divide it by 2. So to solve this, we can multiply by 2. And we have 5x plus 6 when I combine those like terms. So I did 2 steps at once. I got rid of the denominator and then I combined my like terms. Do you guys see that? Then to get x, I would subtract 6 and divide by 5. So x is 12. So if x is 12, all we have to do is substitute that in. So TR is 2 times 12 minus 3. 24 minus 3 is 21. PA is 3 times 12 plus 9. So that's 36 plus 9, which is 45. Are there questions on that one? So make sure you're staring at your properties, okay? Do we have questions on anything up there?